Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. Let's look at how we evaluate the indefinite integral of the square root of a² minus x² dx, where a is a constant. To do this, we need to make a substitution. So let x equal a sine theta. The derivative of x with respect to theta is a cos theta, and it therefore follows that dx is equal to a cos theta d theta. If we now substitute for x and dx in our integral here, we have the integral of the square root of a² minus a² sine² theta multiplied by a cos theta d theta. And if we take the common factor out of this expression, we have the integral of the square root of a² into the bracket of 1 minus sine² theta multiplied by a cos theta d theta. And using the trig identity where cos² theta is equal to 1 minus sine² theta, this simplifies further to the integral of the square root of a² cos² theta multiplied by a cos theta d theta. So taking the square root and then multiplying by a cos theta d theta, we're left with a² multiplied by the integral of cos² theta d theta. And this evaluates to a² into the bracket of theta divided by 2 plus sine 2 theta divided by 4 plus a constant of integration c. If you're wondering how I evaluated this integral, then please see this video. I'll drop a link to it in the description. So now we know that x is equal to a sine theta, and therefore theta is equal to sine to the minus 1 of x divided by a. And substituting back in for theta gives us a² into the bracket of sine to the minus 1 of x over a divided by 2 plus the sine of 2 multiplied by sine to the minus 1 of x over a divided by 4 plus a constant of integration. Now the sine of 2 sine to the minus 1 of x over a simplifies to 2x multiplied by the square root of a² minus x² divided by a². So now if we substitute this expression back in here, we get our final answer, which is a² multiplied by sine to the minus 1 of x over a, all divided by 2, plus x multiplied by the square root of a² minus x², all divided by 2, plus a constant of integration.